starts beginning. Thank you all, and thanks for inviting me. And it's great to be here, especially since I realize that my talk is now over looking at the clock. This is actually a daunting kind of thing. I was asked to give a 10-minute talk on everything that's going on in metadata in biology and medicine. I teach an entire course on this. It takes about an academic term. So I'm going to talk very fast, and I'm going to do a couple. I'm already doing that. I'm going to do a couple of things. I'm not going to say anything about my project or about the projects of the biologists who are also around the table, because I think we will have an opportunity to speak up a bit later. But what I want to do is give you a flavor for the landscape of what's going on in the life sciences and on the clinical side, so that at least you get an idea that there's this flurry of activity. And I think what's very important for this group is to understand really what those flurries look like, to understand particularly on the side of the life sciences how the data deluge has caused investigators to actually organize themselves and to try to address some of the data problems and the metadata problems that they have to deal with in order to be successful in their work, which is easy to contrast with the clinical side of things, where largely the metadata are coming from the vendor community, which have commercial interest in being able to have their systems interoperate, and more important, from government. And we can talk about some of the implications of that. On the life sciences side, every year, nucleic acids research publishes information which is widely anticipated and widely dreaded, because what they do is they catalog all of the biomedical databases that at least that they know of. And there are literally thousands of biomedical databases that can be reported in NAR. And our goal, of course, as scientists is to try to understand what's out there. Much of that is very, very complicated to find, very difficult, as you can all imagine. And as a consequence, there's a lot of work going on among the scientific community simply to deal with the fact that there's just too much stuff to be able to know what exists. An activity which I think is important, not as well recognized in the community as you would imagine, but still absolutely essential, is the BioSharing Initiative that Susanna Sansoni leads out of Oxford. Lots and lots of collaborators, lots and lots of people helping out on in this activity, where the goal is to try to catalog not only the various data sets that exist there, but policies regarding data curation and data management, standards, as we see here, for data formats, for terminologies and ontologies, and all the various checklists, which I'll talk about in a moment, which allow experimentalists to make sure that when they report their data, they're actually remembering to say all the things that they should about a particular experiment. And then also an enumeration of the databases that basically is building off the NAR activity, but more important, an activity called BioDB Core, which has the goal, very long term, of trying to come up with ways by which we can create data dictionaries in biology, where as much as possible, information about biomedical experiments can be unified. This is all at a very, very early stage, but essentially the International Society for Biocuration is involved in trying to come up with, I would say, informal standards that would allow our databases to use metadata that are more similar, so that we can have a better idea of how to integrate those databases in the longer term. As you already know, the explosion of high-throughput experimentation in biomedicine has caused serious problems with data overload. I think the advent of DNA microarrays 15 years ago or so really has been the major driving force for a lot of the activity that we're seeing in biomedicine now. And when microarrays came out, it became clear that there was so much you could say about these kinds of experiments that it was necessary to come up with, if you will, a checklist to be able to be certain that your experimental description was complete. And so the minimal information about a microarray experiment initiative, or MIAMI, became a mechanism by which the biologists who were involved in doing these experiments got together with no one telling them they had to do so, and developed a mechanism by which people who publish about microarray experiments can make sure that they are able to talk about the kind of the chips, the experimental conditions, the object of the study, and so they can make sure they get it all right, so that when they publish in journals and when they put their data online, all that information is there. And basically now, the Gene Expression Omnibus at NLM and Array Express at EBI and a lot of other repositories are insisting that the Miami standard be used to describe these kinds of experiments. But not only do we have Miami as a checklist, but what was then the Microarray Gene Expression Data Society, now the Functional Genomics Data Society, has moved on beyond the checklist to actually develop a markup language that's either in XML or Excel that can actually provide even more information, more specific information about microarrays and ontology. And that MGen ontology is now exploding into something which not only is going to be an ontology to talk about functional genomics experiments, but basically all experiments in biomedicine. Susanna Lewis can talk more about that. She's involved in that initiative to create what is an ontology of all biomedical investigations. A very noble goal, obviously a very ambitious project. Microarrays are great, but there are lots of other kinds of experiments in biology. And what's very interesting is that once the Miami standard got on board for microarrays, well, you can see here a lot of other minimal checklists became available. The minimal information about a cellular assay, minimal information about a microarray experiment, minimal information about a phylogenetic analysis, yada, yada, yada. And part of the BioSharing Initiative is this MIBI initiative, which is minimal information about a biological or biomedical experiment. Anyway, which tries to catalog all of the minimal information checklists, of which there are many dozen. And what you see here is an initiative basically, again, stimulated by the biologists, recognizing that their experiments are complicated. It's easy to screw up when you create data or metadata about these experiments. And this really is an important example of a ground-up kind of initiative to try to develop the metadata that will hopefully allow people to make sense of these experimental contributions. That's very different from what you see in the clinical side. On the clinical side of the world, we have Health Level 7, which is essentially a trade organization founded by some academics and by the vendors trying to come up with mechanisms for standardizing information that needs to be communicated among the components of information systems in the healthcare setting. HL7 began initially as an organization trying to come up with a standard for message passing. I show you this ugly message to show you how ugly the problem has been. The idea of being able to pass information from a pharmacy system to a lab system to the admissions and discharge system of a hospital. And HL7 has moved beyond these kinds of messages to a much more ambitious program of trying to help with the management of the clinical enterprise through metadata. And perhaps one of the most important things that they have done is to create what they call a reference information model, which is an enormous object diagram represented, not in UML, I'm afraid, but actually a variation of UML, just to make life interesting, which has been around for a while, but it actually has had some serious problems getting adopted. People are a little bit leery of the reference information model that HL7 has created to try to identify everything that takes place in the clinical arena, mainly because it's so big, it's so complicated, it's so hard to understand, and people fundamentally lack confidence in it. And there are lots of issues that we can talk about later relating to the RIM that HL7 is advocating. There's been a committee that has been formed since 2011 called the Fresh Look Task Force, which is basically HL7's response to trying to understand why the RIM has had the limited adoption that it's had. They have recently proposed a framework called FHIR, F-H-I-R, which is still very early, very difficult to actually make any summatory assessment of it. But FHIR basically still uses the best of the RIM, if you will, but recognizes a lot of the detail on the RIM is probably overkill, also tries to make life more simpler by adopting a more modular approach to the building of metadata relating to the clinical enterprise. And we'll see how this initiative goes. But this is what the HL7 community is doing. They're also talking about models such as the clinical document architecture model, which is the foundation of health information exchanges, the kinds of networks that allow hospitals and other healthcare organizations to pass data back and forth. The continuity of care document is a derivative of the CDA, a different kind of standard, but the one which ONC is now advocating is the basis of the transfer of information, and something that you will find, for example, is the basis of Microsoft Health Vault, for those of you who care about personal health records. The continuity of care document and the other HL7 standards are looking at clinical data as documents, the way electronic health records tend to look at clinical data. And what's interesting is that although everybody recognizes the importance of moving from the paper-based world to an electronic world in the clinical enterprise, essentially what people are doing is taking the paper-based medical record and translating it into an electronic form, taking a paper-based document and moving it into an electronic document. What has happened in the past couple of years is a proposal which is radically different and something which ONC is now paying a lot of attention to, which is a result of the PCAST report that came out about 3 years ago. And the PCAST report basically argued that what we really need to do is stop looking at clinical data as documents as if they came out of a paper chart. What we want to do is look at the data in the clinical enterprise individually. We want to be able to ascribe to each datum information about its provenance, about the degree to which the patient who contributed that data wants that data item to be shared, with the idea that data will be stored in a distributed fashion on an element-by-element basis, and that we would have clients on the internet that would be able to go out to these servers and almost magically, if you will, bring all the various data elements together to construct a presentation of the information, which would be comparable to what you would see in a clinical document, where the data themselves would be distributed, where they would each be associated with enormous amounts of metadata describing where they came from, how they come together, and what the security considerations are for each data element. As you can imagine, this approach is very different from what the vendors in HL7 are arguing for. This approach is something that the vendors are very leery about, though ONC has said that they view the PCAST blueprint as the way they want to move forward, and I think it's going to be very interesting to see on the clinical side how the interplay between the PCAST recommendations and HL7 will play out in the future. So, I can catch my breath. Fundamentally, I think we all understand the enormous amount of high-throughput data in the life sciences. We understand the enormous amount of data that come out of electronic health records in the clinical enterprise on that side. I think what we see on the life sciences side, an enormous effort on the part of health scientists around the world working together from the grassroots, trying to create the standards that will allow them to make sense of the data that they generate. Certainly in the United States, a lot of top-down work on the part of government agencies and vendor communities in order to create the metadata necessary for the interoperation that we're looking for in clinical medicine. And as always, we have more standards than we know how to choose from. But I think what's really very interesting is that although the biologists themselves have done a wonderful job of creating a lot of metadata opportunities, those standards have not had the penetrance that we'd like to see. And on the clinical side, a lot of the standards, both from HL7 and from discussions in the government, have met with, I would say, open hostility.